I'm going to go through a few more examples involving probability of at least one and conditional probability to help you review for your test. If you recall, the probability of at least one is equal to 1 minus the probability of none. Now, to use this formula, let's look at the following example. If the probability that South Florida will be hit by a hurricane in any single year is 5/19, what is the probability that South Florida will be hit in 4 consecutive years? This is the probability that South Florida is hit in the first year, and in the second year, and in the third year, and in the fourth year. Since this is an and problem with multiple events occurring, we're multiplying the probabilities. The probability that South Florida is hit in the first year is going to be 5/19, and that was provided in the problem. Now, if South Florida is hit in 1 year, that doesn't affect the probability of it being hit in the second year. These are independent events. So the probability remains the same for all 4 years. When you multiply this across, we get a decimal of 0.0047 or 48 if we round. Now, if we scroll down, what is the probability that South Florida will not be hit in 4 consecutive years? Well, that's the probability that the first year they're not hit, and the second year they're not hit, and the fourth year they're not hit. I think I missed the third. That's okay. So it's the probability that they're not hit times the probability that they're not hit times the probability that they're not hit times the probability that they're not hit. Now, if the probability that South Florida is hit is this 5/19, then that means that the probability that they're not hit is 14/19. Because those are complements of one another, if the probability that South Florida is hit is 5/19, to find the probability that it's not hit, subtract from 1. When you multiply this, you get 0.2948. What is the probability that South Florida will be hit in at least one of the 4 consecutive years? The probability of at least one is equal to 1 minus the probability of none. And in the context of this problem, what that's saying is that it would be 1 minus the probability that it's not hit in 4 consecutive years, which we just calculated in part B. So if I subtract, I get 0.7052. In class, we discussed the definition of dependent events. Those are events that the occurrence of one affects the probability of a second, and the conditional probability is just that affected probability. Let's look at a few examples for that. Find the probability of being dealt 2 kings. That's being dealt a king and then another king. Now, this second probability is the probability of being dealt a king, assuming that we've already been dealt a king. So the chances of, or the probability of being dealt your king first is 4 out of 52 because there are 4 kings out of 52. Now, assuming that we're dealt a king, what's the probability of being dealt a second king? Well, if I've already gotten one of them, there's only 3 remaining. And I've already been dealt one card, so there's only 51 cards left. This fraction simplifies to 1 over 221, or as a decimal, 0.0045. Find the probability of being dealt 3 hearts. It's the probability of being dealt a heart times the probability of being dealt a heart second times the probability of being dealt a heart third. The probability that your first card being dealt is a heart is 13 over 52. There are 13 hearts in the deck. Now, assuming that your first card was a heart, the probability that your second card is a heart is now 12 over 51, because there's one less heart and one less card in total. Assuming that your first 2 cards are hearts, the third card has a probability of 11 over 50 for being a heart. This fraction simplifies to, I'm not sure, I can't read my calculator, but the decimal is 0.0129. Something over 850. A letter is randomly selected from the English alphabet. Find the probability that the letter precedes H, given that the outcome is a vowel. Now this right here tells me something about the outcome. I know that the outcome is a vowel, which changes the possible number of outcomes. To find probability, it's the number of ways your event occurs over the total possible number of outcomes. If my outcome is guaranteed a vowel, there's only 5 possible outcomes, A, E, I, O, U. Now, the probability that the letter that we select precedes H, precede means to come before. How many vowels come before H? Only A and E. That's 2 over 5. You are dealt 1 card. Find the probability of being dealt a black card, given that the card is a spade. Again, we're being told something about the outcome. We know that the outcome is that we have a spade. So how many spades are there? There are 13. Now, the probability of being dealt a black card involves determining how many black spades are there. Well, all of my spades are black, so there are 13 of them. The probability of being dealt a black card, given that the card is a spade, is 1. Find the probability of being dealt a spade, given that the card is black. Again, if we know that the card is black, that's telling us something about our outcome. There are exactly 26 black cards in the deck. Of that, how many of them are spades? There are 13 of them that are spades. This simplifies to 1/2. The following table gives mammogram screenings for breast cancer of women aged 40 to 50. Find the probability that a woman has a positive mammogram given that she has breast cancer. Again, this is telling me what my outcomes are. So to find the probability, we're now limiting our outcomes to just those that have breast cancer. From this table, the number of women with breast cancer is 800. Now, of that, how many had a positive mammogram? 720. This simplifies to 9 over 10, or 0.90. Find the probability that a woman has breast cancer given that she has a negative mammogram. If the woman has a negative mammogram, there were 92,336 of them. And we want to know the probability that that person had breast cancer. Oops. Yes. this is 80. The 80 column is for breast cancer. Now that's very small. Your calculator may or may not simplify this, but as a decimal, it's 0.00049. So very, very small probability. A family has 2 children. Assuming boys and girls are equally likely, determine the probability that the family has 2 girls. So this is the probability that the first is a girl and the second is a girl. The probability that the first child is a girl is 1/2. The probability that the second child is a girl is 1/2. So the probability that the family has 2 girls is 1/4. Find the probability that they have 2 girls given that at least one child is a girl. Now, again, we know that at least one of the children is a girl, but I want to know the probability that if at least one is a girl, that they had 2. To do this, we're going to actually construct a tree diagram of all of our possible outcomes. So for the first child, there were 2 options. They could have a boy or they could have a girl. If their first child was a boy, they could have a boy or a girl second. If their first child was a girl, they could have a boy or a girl second. And this gives all 4 of my possible outcomes of having 2 children. So in this example, they want the probability of having 2 girls given that at least one child is a girl. So how many of these 4 outcomes have at least one that's a girl? Well, the first one is boy then boy, which doesn't count because it doesn't have at least one girl. Boy then girl, there's one. Girl then boy, that's another one. Girl then girl, that's another. So there are 3 outcomes in which there's at least one girl. Now, of those 3 outcomes, so this one, and this one, how many of those had 2 girls? Boy, girl, girl, boy, girl, girl, there is 1. Find the probability of the family having 2 girls given that the older child is a girl. Now this column represents my first child, this one represents the second child. So now we're only looking at the case in which the first child was a girl, so there was only 2 possible outcomes of that. The probability that they have 2 girls given that the first child was a girl, there's 1 out of those 2 that have 2 girls.